Hello students, we are solving the IB Math AHL past papers and currently we are solving the IB Math AHL November 2021 paper 1. Today we will be solving question number 11 of this paper and you will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlists in the description area. So without any further delay, let us start answering question number 11. The maximum mark is 14 and subpart A says prove by mathematical induction that the nth derivative of x squared times e to the power of x equal to x squared plus 2 times x plus n times n minus 1 whole multiplied by e to the power of x for n belonging to the set of positive integers and it contains 7 marks. But it is a very easy question because it is quite an easy question, definitely, right? Because we know how to differentiate, so we can, of course, solve this. Fine, first of all, we have to, since it is n belongs to the set of positive integers, that means the first value of n will be 1. So let us see what are we having when n is equal to 1, okay? So when n equal to 1, that means we will be having the first derivative. Therefore, ddx of x squared times e to the power of x, we will be using the product rule, of course. So it will be 2x times e to the power of x plus x squared times e to the power of x. Okay, and this can be written as, since they have written x squared first, let me write x squared first. And this is 2x, so I can write this as 2 times 1 times x, and this is plus 0. So this can be written as, I'm just trying to write this as in this form. So this is n equal to 1, so this is 1 times 1 minus 1, which is 0. Times e to the power of x. So, therefore, the given relation is true when n is equal to 1. Okay? Let it be true. Not having much space. I have solved mathematical induction questions in the previous papers in an elaborate way. So over here, I'm just curtailing some part, but I'm writing all the essential parts. Okay? So if you want, you can see the exactly what all steps you have to write. But in case you have time, but in case you don't have to time and don't have much time, you can just you have to show the essential steps which I am showing over here. Okay. So let it be true for n equal to k. K belongs to the set of positive integers. Okay. Therefore, the kth derivative of x squared times e to the power of x is equal to x squared plus 2kx plus k times, I'm just putting k in place of n, k minus 1 all multiplied by e to the power of x. Okay, is true. Now we have to get the k plus 1th derivative. Of x square times e to the power of x. So I can write this in place of this. That means I am differentiating this expression because this is the expression for the kth derivative. And now I am trying to get the k plus 1th derivative. So if we differentiate this, we will be getting the k plus 1th derivative. So that is what we will be doing. So this is x square plus 2kx plus k times k minus 1 e to the power of x. Again, I'll be applying the product rule. So it is 2x plus 2k times e to the power of x plus x square plus 2kx plus k times k minus 1 and e to the power of x. Okay, fine. So now, since both the terms are having e to the power of x, I can take e to the power of x common. And I'll be writing e to the power of x last of all. So I am taking 2x plus 2k plus x square plus 2kx and plus k. This one is k, okay? This one is k, this one is k. Plus k times k minus 1. This is equal to, first of all, there was x square. So let me write x square. I have to maintain the same format. So I'm writing x square, then the term contains x. So I'll be getting the term containing x. From here we are having 2 and this is 2k. So let me just take out 2x common. Okay. So, and this is x. So from here I am getting 1. And from this I am getting k. And then we have taken this one, and this one. Now coming to the constants. So, and we know that we should be having k plus 1 times this will be when n equal to k plus 1, what should we be getting? It should be k plus 1 and k plus 1 minus 1, which is k times k plus 1. So we should be getting this. Okay. So let us see. Let us see. So we are at least having k common. So let me get k common. And from here we are getting the number 2. And from here we are getting k minus 1. Okay. And e to the power of x. So this is x square plus 2 times k plus 1x. And this is 2 minus 1 is 1. So plus k times k plus 1. Or let me write, this is k plus 1. So k plus 1, and this k I am writing as k plus 1 minus 1. Okay, because should be getting k times k plus 1, but I'm just writing it in this format. So n and n plus n minus 1. So it is when n equal to k plus 1, it is k plus 1 times k plus 1 minus 1. And e to the power. Okay. Therefore, the relation or equation is true for n. This is when n equal to k plus 1. For n equal to k plus 1, when it is true for n equal to k belonging to the set of positive integers. Okay. The equation is true or the relation is true, whatever you write, for n equal to k plus 1 when it is true for n equal to k, where k is a positive integers. Therefore, the equation is true for all n where n belongs to the set of positive integers. Okay, so proved. So this was the subpart A. Let us move on to subpart B. Subpart B. Hence or otherwise determine the Maclaurin series of f of x equal to x squared times e to the power of x in ascending powers of x up to and including the term in x to the power of 4. And it contains 3 marks. What is the Maclaurin series expansion? It is f of x is equal to, provided it is a continuous thing, and f of 0, f dash 0, f double dash 0, all these exist. So then it is f0 plus x times the first derivative and then x squared over factorial 2 second derivative plus the third derivative plus fourth derivative and so on. It is an infinite series. So we have to get f of x expansion, the expression. So f of x is what? X squared times e to the power of x. And in order to get this, we have to know the values of f of 0, f dash 0, and although I have written up to x to the power of 4 because they have asked for up to x to the power of 4. Okay? But otherwise, it is an infinite series. So first of all, let us just get the values of these f0, f dash 0, and so on. So f of 0 will be equal to f of x is x squared times e to the power of x. So x is 0. 0 square times e to the power of 0 is equal to 0 times 1 is 0. F dash 0. Now for this, that is why they are saying hence or otherwise. Why? Because over here from this expression, this was given in subpart A. We may use this expression to get the derivatives, or we may just differentiate x squared times e to the power of x expression and get the different derivatives. Okay? But why should we be working extra? So we will be just taking the help of this given equation. So when f dash 0 means it is the first derivative, that means the n value should be equal to 1. So this will be equal to 0 squared. You may just write this as if nx equal to, that is the nth derivative. So this is equal to x squared plus 2nx plus n times n minus 1 whole to the whole multiplied by e to the power of x. Okay? You have to just, it is better because this is given in this form. So you just write one line and then you can just substitute 0 in place of x and you get the approximate value, the value of n. You take the relevant value of n and you get the value of f dash, f double dash and so on. So f dash 0 will be 0 squared plus 2 times n is 1 in this case. So 2 times 1 times 0 plus 1 times 1 minus 1 e to the power of 0 equal to, this is 0, this is 0, even this is 0. So 0 times 1 is again 0. Fine. And what is f double dash 0? Let us check. Again 0 square plus 2 times, this time n value is equal to 2. 2 times 0 plus 2 times 2 minus 1. This is at least one of the non-zero numbers we are getting. Okay, so this is 0, but this is 2 times 1 is 1. And this is equal to e to the power of 0 is 1. So 2 times 1 is equal to 2. Okay, fine. So again, let us get the third derivative equal to 0 square plus, this time n value is equal to 3. Again 0 plus 3 and 3 minus 1 e to the power of 0. So this is 0, this is 0, this is 3 times 2 is 6, 6 times 1 is 6. If the fourth derivative, so this is again 0 square plus 2 times 4 times 0 plus n equal to 4. So 4 times 4 minus 1 e to the power of 0. 4 times 3 is 12, 12 times 1 is 12. Okay. So now we write f of x is equal to x square times e to the power of x is approximately equal to, because we are taking only the first 5 terms. Okay, so that is why is approximately equal to f0 is 0 plus x times f0 f dash 0. So x times 0 plus x square over 2 if double dash 0 is 2 plus x cube over factorial 2 factorial is 2, that is why I have written 2. 3 factorial is 3 times 2, which is 6, and the this one is 6. Then x to the power of 4 over factorial 4. 4 times 3 is 12. 12 times 2 is 24. Okay. So 4 factorial is 24. And this one is 12. So up to x to the power of up to term in x to the power of 4. This is equal to, or again I'm writing this, f of x equal to x square times e to the power of x is approximately equal to, these two get cancelled, and this is 2. So this is x square plus x cube plus half times x to the power of 4. Okay, this is our answer. Okay. So we have completed solving subpart B. Let us move on to the next subpart. Subpart C. Hence or otherwise determine the value of x squared times e to the power of x minus x squared whole raised to the power of 3 over x to the power of 9 limit x tends to 0, and it contains 4 marks. Hence or otherwise, what does this mean? Hence or otherwise means if you use the hence part, that means in our subpart B, we had found the first 3 non-zero terms of this function expression x squared times e to the power of x. We may substitute those 3 non-zero terms over here in place of x squared times e to the power of x. Those were x squared plus x to the power of 3 plus half times x to the power of 4. And x squared minus x squared will be getting cancelled. So we will be having x cubed plus half times x to the power of 4 whole raised to the power of 3 divided by x to the power of 9. And you can expand and simplify and get the limit x tends to 0. This is the hence part. What about the otherwise part? I'll be doing the otherwise part. I could have done the hence part also, but let me show you the otherwise part. What is that part? We will be using the L'Hopital's rule. For that, we have to first of all show that this is an indeterminate form. It is a 0 by 0 case. Okay. So let us do that. Okay. Before showing that it is an indeterminate form or it is a 0 by 0 case, let us just simplify it a little. Limit x tends to 0 and it is, let me take x square e to the power of x minus 1. This whole thing is getting raised to the power of 3. And x to the power of 9. Actually, this is this way. And this is x to the power of 9. So this is limit x tends to 0 x to the power of 6 and e to the power of x minus 1 whole raised to the power of over x to the power of 9. Okay, and this, it will be getting cancelled, and we will be having limit x tends to 0, e to the power of x minus 1 whole raised to the power of 3 divided by x to the power of 3. Okay, which can be written as limit x tends to 0, and this is e to the power of x minus 1 over x whole raised to the power of 3. And you see e to the power of 0 is 1, so 1 minus 1 is 0, and when x is tending to 0, so the denominator is also 0, so this is a 0 by 0 case. Therefore, using L'Hopital's rule, we have limit x tends to 0, and it is d dx of e to the power of x minus 1 over d dx of x. This whole thing is getting raised to the power of 3. This is limit x tends to 0, d dx of e to the power of x minus 1 is e to the power of x. E to the power of x, and this one is derivative of x with respect to x is 1 to the power of 3. And now when x is tending to 0, e to the power of 0 is 1, so this is equal to 1. 1 cube is 1. Okay? So the answer is 1. Okay? And we have got 4 marks, and we have completed answering question number 11 completely. Okay? And I'm Nilanjana Seniyal. I tutor IB Math A, SL and IB Math A HL level students within India and outside India. And I'm starting small group online tuition batches and for grade 11 students who will be having their board examination in 2025. So in case you are interested, you are having my WhatsApp number getting displayed, you are seeing my email ID getting displayed, you may contact me for more details. Okay? And thank you for staying with me till the end. We meet again very soon in our next session where we'll be solving the last question of this paper, that is question number 12. So till then, bye.